Hello everyone, welcome back to my YouTube channel Trouble Free. In today's video I'm going to explain you about branch and bound algorithm in the subject of design and analysis of algorithm. So basically in this video I will explain you what is branch and bound algorithm, what are the applications along with a numerical problem. In the next coming videos we will learn about the applications of this branch and bound. Okay, so without any further delay, let's get into the video. We are using this branch and bound in order to find the optimum solutions. Optimum solutions means the best solution. That means we have to get more profit. Okay, we always should concentrate on getting more profit. So it is similar to backtracking, but in backtracking we are using depth first search. In branch and bound we are using BFS, breadth first search. Depth, here it is depth, here it is breadth. Okay, you know what is depth first search, right? You are searching by depth. Breadth means you are searching by breadth of the tree. Okay, here what do you mean by branching? It is the process of generating sub problems. You are generating multiple sub problems, and in which you will decide which sub problem you have to choose so that you are getting the maximum profit. Okay, so and we are using the concept of state space tree here in all the problems in branch and bound, and in the applications of branch and bound we will use the state space tree. It will have all the possible paths. Okay, and after finding all the possible paths, what we are doing, we are trying to extend the cheapest path in the sense the path which will give you maximum profit with less cost. Okay, here optimum solution means what? You have to get maximum profit but the cost should be less. That is our main aim. We have to work towards it. And now what are the applications? We have two applications. We have traveling salesperson, which we will learn in the next video, and after that we have 0 by 1 knapsack problem. We will have 0 by 1 knapsack problem in the dynamic program approach also. Dynamic programming approach, that is different. Different in the sense that goes according to the dynamic programming approach, this goes according to the branch and bound. And in 0 by 1 knapsack also we have two categories, least cost knapsack and FIFO. So we are learning 0 by 1 knapsack with branch and bound algorithm. In that also we have two things, LC, least count, and FIFO, branch and bound. Okay, so now for this video let us go into the numerical example of branch and bound. So just be patient guys. If you are getting confused at any point of the video, just pause it, go back, watch again. If you're still not able to understand, let me know in the comment section. Okay, chalo, let's get into the example now. So this is our example. This is the graph. Here our goal is to start from here and reach this node. So from S node to G node you have to travel, you have to reach with low cost. Okay, whatever possible low cost is there. There are different paths, right? You can go this way, you can go this way, you can come in this way, or you can come in this way. There are so many ways. Among all these ways, whichever way is having lowest cost, that you have to find out using branch and bound technique. Okay, so let's get started. So this is start node and this is the end node. Okay, now so let me zoom in a bit so that, yeah, this should be good. Let's try. If this is not sufficient, let's zoom in more. So first what we are doing is, what is our starting state? S, right? So we are taking S first. S is our starting state. So from S, where you can go? From S you can go to A and you can go to B, right? So from S you can go to A and you can also go to B. I suggest you to take a screenshot of this or draw it on a piece of paper because we will be moving between different papers. Okay, so yeah, what is our first state? First state, start state is S, right? So this is the starting state. From S we have two different options. You can either go to A or you can go to B, right? So let's go to A and you also have chance to go to B. So to go to A, what is the cost? It is 3, right? So let us write 3 over here. And to go to B, what is the cost? 6. So you're done with the first step. From S you have 2 options, and among those 2 options, whichever is the smallest, you have to pick, because our aim is to get with a low cost, right? We have to concentrate on getting low cost. Now A is the lowest cost among both these two. So now you have to start extending A. Okay. From A, what are the different paths you have? From A, you have chance to go to C, you have chance to go to S, and you have chance to go to D, right? So let's extend A. You can go to C, and then you can go to S, and then you can go to D also. So from A to C, what is the cost again? It is 7. From S to A, it is already 3, right? So 3 plus 7 will give you 10. So 10 is the cost to reach C. Now from A to S. From S to A, it was already 3 units. Again from A to S, what is the cost? 3 units. So 3 plus 3, you will get 6 here. Now from A to D. From A to D, what is the weight? 2. So, till here it is already 3. So 3 plus 2 will give you 5. Okay. So this is about A. Now what are your leaf nodes of the tree? So at this point, in the first iteration, your leaf nodes were A and B. Okay. Among A and B, you have picked to extend A, because A is having lowest weight. Now in the second iteration, among C, S, D and B, what is having lowest cost? D is having lowest cost, right? So now you have to pick to expand D. Why? Because among 10, 6, 5 and 6, what is having lowest cost? D. So you have to start expanding D now. From D, what are the different paths you have? Look at this graph. From D, you have chance to go back to A, you can go to B, you can go to E, and you can go to G. You have 4 different options to go from D, right? A, B, E, G. Let's write the same thing. From D, A, next B, next E and G. E and then to G, right? Do you have anything else? A, B, E, G. Yes, that's all. Now till D, it is already, from S to D, it is already 5 units of cost. From D to A, how much it is? 2. 5 plus 2 is 7. Next, from D to B, D to B, it is 3 units, right? And here it is already 5. So 5 plus 3 is 8. Next, to E, let us see. D to E. D to E, it is again 2 units, right? So 5 plus 2 is 7 again here. Next, simple guys, just look at the number which is on the previous node. Don't get confused. Now from D to G. D to G, it is how much? 4. Till here it is already 5. So 5 plus 4, 9. And here what you have to notice is, you have already reached G. G is your goal state, right? So at present, your total cost to reach G is 9. Okay, at present. So now you have to not stop here. You have to still check, and after checking, if you still find out that if there is any value which is less than 9, then you can go for that value. Otherwise, you can pick this path only. Okay. Now let's see. So in the third iteration, what are your leaf nodes? C, S. So whatever nodes are left out without branching, you can pick all those nodes as your leaf nodes. A, B, E. G is of course a leaf node, but you don't have to expand it further, right? You have already reached there, so you can leave this, and then you have B here again. Okay, so among all these you can straight away eliminate C. Why? Because it is already greater than 9. So till now what is your total cost to reach G? 9. It is already greater than 9. Still, if you expand it further, what will happen? It will be obviously more than 10, right? So you can straight away eliminate C. So you are remaining with S, A, B, E and B, right? Among all these, again you have to pick the minimum value. Among all these other values, what is having minimum? S with 6, and then A, B, E, G, again this B with 6 again, right? So S and B are having 6. So now you have to check for the S and B, which one is better for us. Okay, first let's check for B. So from B, where you can go? From B you have chance to go to D, and you have chance to go to E, and you have chance to go back to S. So let us calculate the cost now. So from B, where you can go? You can go to S, and then you can go to E, and then you can go to D. Okay, now let us calculate the costs. So from B to S, how much it is? 6. Here it is already 6, right? So 6 plus 6 you will get 12. The cost to reach from B to S is 12. S to B and B to S, it is 12. Now the cost from B to E. B to E, what is the cost here? 6. What is the already here what we have? 6. So 6 plus 6 you get 12. Now what is the cost from B to D? B to D, here what do you have? 3. So 6 plus 3 you will get 9. Okay, so here also straight away you can eliminate this S and E. Why? Because they are already greater than your total cost. You have not reached G, you have to still do further branching to reach G, right? When you're doing further branching, obviously the cost will increase. So obviously you will get some value which is greater than 9, and you don't want that. So you can straight away eliminate this S and E. Okay, and here D also you got this as equal to 9. So if you still further branch it, then you will get something which is greater than 9 only, obviously, right? So you can delete this D also. So B, so this path is obviously deleted. Now what do we have more? S. Let us check for S. So S, do we have space here? No, it will become congested, guys. I'm doing it here. This S, I'm bringing it here. So from S again, where you can go? From S you can go to either A or B, right? So from S you have chance to go to A, or you have chance to go to B. So from S to A, so from this S to A, what is the cost? From S to A it is 3. Here you already have 6, right? You are already having 6 here. So 6 plus 3 will give you how much? 9. So from S to B, S you already have 6 here. On this S you already have the weight of 6. Okay, and from S to B it is 6. So 6 plus 6 will give you 12. Got it? So here also again same story. B, it is directly greater than 9, which is our total cost at present. So you can eliminate B, and A, it is equal to 9. So if you do further branching, what will happen? You will get something value which is greater than 9. So here you cannot, A is also deleted. That means you have to delete this entire S, and this entire B is also deleted. So S is gone, B is gone. What are your remaining options? A, B, E, right? Now let us work on A, B, E. So among A, B, E also, which is having minimum cost? A is having, A and E are having minimum cost, right? You have to do either A or E first. Let's start with A, okay? Or let's start with E. So from E, where you can go? From E you have chance to go to B, D and G, right? So from E you can go to B, D and G. B, D, G, yeah, we are right. So now let us try to calculate the cost. So till E it is already 7, right? So from E to B, what is the cost? 6. 7 plus 6 is 13. From E to D, what is the cost? 2. 7 plus 2 is 9. From E to G, what is the cost? 1. 7 plus 1 is 8. So now, what was our total cost previously to reach G? It was 9, right? Now what did you get the total cost as? 8. So we have to update our total cost with 8 because we got minimum cost. We got something value which is less than 9, right? You have to update. Okay, we have updated. Now, so okay, we got something with E. Let us consider E. Now what do we have still remaining? A and B are the still remaining leaf nodes, right? Let's check for A and B also. B, you can actually eliminate it. Why? Because the total cost is 8 and there is no point in expanding B, because obviously you will get some value which is greater than 8 that we don't want. So you can just delete B also. Just check for A and that should be enough. From A, where you can go? From A you can go to C, D and S, right? So from A you can go to C, you can go to D and you can go to S. Now let us try to find out weights for this. Actually you need not find out the weights also because there is no G here, but still let's do it. Let's go according to the what do we say, process. So yeah, from here already the weight on A is 7. Okay, from A to C, what is the cost? 7. 7 plus 7 is 14 here, and A to D it is 2. So 7 plus 2 is 9, and from A to S it is 3. 7 plus 3 is 10. 14 is greater than 8. You can delete this. 9 is greater than 8. Delete this. S is greater, 10 is greater than 8. Delete it. Okay. You have finished checking all the leaf nodes, right? So at this point you can stop because you got the minimum solution already. So till now, if you extend anything also, you will get something which is greater than 8 only. So you can stop your solution at this point. You may get a doubt like, when do we have to stop our solution? When the weights of all the leaf nodes is greater than or equal to your current total cost, you can stop the process. Okay. So now what is our path? From S we came to A, okay, and then from A we came to D, okay, and from D we came to E, right? Yeah, from D we came to E, and from E we came to G. I will write here S to A to D, and D to E, and E to G. From D to G also we came directly, but the cost was 9, right? But here we got 8. So we are picking this way so that we are getting our goal with least cost optimization, right? You have to search for least cost. So guys, let me quickly brief out the process for you. This is your graph. This is the starting state, this is the end state. Your goal is to travel from starting state to end state with lowest cost. So first you're starting from S. So from S you have possible paths to A and B. Among A and B you have to pick the minimum path, that is A. So again from A, what are the possible paths you have? S, D, C. Among S, D, C, what is the minimum path? That D. You are picking D. For D you got so and so root nodes. By considering at every iteration you have to consider all the root nodes. Okay, so for among all the root nodes, whichever root node is having lowest cost, you have to start expanding that lowest cost until you get the goal state with lowest cost. Got it? I really tried my best to explain this in a good way to you, but still I know the video was lengthy, but still if you are able to understand it, well and good. Don't mind about the length of the video. If you're not able to understand, let me know in the comment section. Let's try to do something else so that you can understand it again. Okay, thanks for watching the video till the end, guys. Thank you so much for your patience towards the video.